Okay, example 4 was a lab rat question. I think they were put in a new environment and time to do something, and we were asked to work out whether their new environment was having an impact on the time, so whether the time was different or not. So, because it's not equal to there, this is going to be a two-tailed test. We're doing it at 5%. We have a sample mean. We have an unbiased estimator for the population variance, and we worked that out when we did example 4 last time. So, if you were doing this approach, you would still have had to work that out, which we'd worked out last time. It wouldn't just be necessarily given to you. But given we have already worked that out in the past, I'm just going to go straight to my diagram. In terms of Z, this is a two-tailed test at 5%, which I think is the most common one you do, really, two-tailed at 5%. And what's the magic number at the bottom for a two-tail 5%?
2.576.
Not for a two-tail 5%. We're looking for 2.5%.
1.696.
1.96, yeah. 2.5% there. So to the left of that line, we are wanting 97.5%. So you're looking in the table at the 0.975 number, and it will come out at 1.96. So two-tail 5% is 1.96 minus 1.96. You will remember pretty quickly the 1.96 figure and the 1.645 figure. Okay, so there we go. So we need to work out our Z value of our sample mean minus our population mean divided by the standard error of the mean. Shall I tell you what it is to save all the tapping going on? Yeah. 2.114. So who's going to tell me what conclusion do I reach? Yeah, that's right, that's here. Okay, that's where my 2.114 is. It's in the critical region, so I will reject H0 and accept H1. So bear in mind that when you do these things for real, they're not necessarily quite as quick as what we have done now, because we did do some background work when we did this the first time round, even on things just like reading the question, which takes a bit of time, which we didn't bother doing now, and writing down your hypotheses and things like that, and in this one, working out an unbiased estimator for the population variance. But it is a quicker way of doing it. Okay? So at this point now, you should be able to go through and do everything in question in chapter 5. For the benefit of those who aren't here now, you need to look on the KRP as well, and there is a homework on chapter 5 which has gone out today, which is due in the first day back after half term in the afternoon, and there's also another everything you've done in S2 so far open book test on the KRP, so you can look at that as well.